All right, guys, welcome to running a Kubernetes cluster at home. Now, a lot of you know that have been following along. I'm doing this in part to help me make some better videos on Kubeflow and GPUs in containers and as an operator. That being said, this is also something that I really needed to do and been planning on doing because my home clusters have been a nightmare of tangled mess. So these have taken a little bit longer because I've been actually trying to plan it through so that my home infrastructure is set up in a really nice way, as well as a way that can be helpful to you guys. Everything that I do here should be pretty repeatable on just about any hardware that you want to do, as well as any networking software. I know that I have some pretty nice Ubiquiti hardware, but any of your home routers are probably going to be able to handle it just fine, so don't worry about that. If you want to know my top 5 OSs for running this on your home, so these would be fully open source projects. You want to look at the Cubic project. They keep things very up to date. It's run on Micro OS, and we're going to run one of those clusters because Micro OS brings the transactional updates to the OS, and it makes this immutable infrastructure. It's pretty cool. So you want to look at possibly that. They also work very hard to keep their packages up to date. After that, you're talking about Fedora CoreOS. It's being brought over from CoreOS, kind of being integrated into Fedora, and it's a very cool project. They're kind of the people that kicked off this Kubernetes-centric OS, so you'll want to check them out. Let's see, top 5. Ubuntu. Ubuntu is the natively supported. Everything just works. It's the Windows of Linux, and I don't mean to taint it with Windows for all of you Linux fans. All I mean there is that they package the world and make sure that most things work for them. So if you're looking to not be fiddling with a transactional update, this might be the option for you. It's very easy to get into, and it's a good OS. Whatever your preferences is, it's a solid OS. All right, moving down the lines, completely open source, ready for home clusters. I said top 5, I've gotten 3. Let me amend that. My top 3 recommendations for your Kubernetes cluster. Those would be my OSs I would choose. Really, you can't go wrong. I know there's a huge Arch following, and I'm sure it works great. I have never run it on Arch. I can't comment to their support. If you want to run it on Arch, Arch is a systemd, right? As long as it's systemd, you should be fine. Any systemd should be fine. If you're not running on systemd, you're a hipster. Embrace it. You know it. All right.
3, 2, 1, 0.
The No Channel.
Welcome to another Kubernetes episode here on the Null Channel. All right, so what are we going to do today? We are actually going to set up the Kubernetes cluster. And I say cluster very loosely here since this is a single node deployment. So really, it's not a cluster of anything. It is a single node that's going to run Kubernetes. And this is going to be most likely what you want to do if you're running it in the home. And I'll give you the reasons I picked it. And really, we're not going to go over the command line. If you're really wanting to see command line, I'm going to throw up a few pictures of some of the stuff that you might see. But I detailed all the instructions in a README. So if you want to follow along with that, they're there. And when the blog is finally hosted on here, they're going to also be able to find it on the blog. So if those are what you're wanting, those are there, and there's no real point. I want to use this time to talk about why I did what I did. The first thing is we're going to set up the cluster with kubeadm. And the reason why. There's a couple ways you could do this. Where you could do a Minikube, and you could actually do Minikube kind of as a real deployment and do some stuff with that. That's not really what I wanted to do. There are some caveats to that, and Minikube is more of a local machine, where this is actually running on a server for my home. And so where Minikube gets a little weird is when you're trying to access it from other machines outside of your local machine, because it wasn't really designed for that. You can do some stuff with like an HA proxy on the machine, proxying the requests, and actually we are going to use HA proxy, but it just wasn't designed for that. And so that's why we're not using it. The other contender that I actually really thought about was K3s, because K3s really would be quite suitable for this. It's would work very well for a home deployment. I didn't pick K3s because one of the reasons I recommend running a home Kubernetes cluster is for the experience, for dealing with all the components. And K3s kind of does all of its stuff in its own way. K3s, uses SQLite instead of etcd. Etcd on a single node doesn't consume that many resources, so I would just use kubeadm because you're going for the experience here. The other thing is when you do it with kubeadm, you're going to get what I would consider a more upstream supported cluster, so a more Kubernetes-centric cluster. And this played into some of our requirements. If you go back to the first video, one of the things I wanted to do is deploy the GPU operator. That's one of the things I wanted to do. And that singular decision there actually made a lot of my decisions for me. So one of the first things it did is the GPU operator supports 2 OSs at all, Red Hat and Ubuntu. So it limited me there. Originally, I wanted my OS to be MicroOS from SUSE, because MicroOS is actually really cool. And I'm probably actually going to run a second cluster in my house on MicroOS, and we're going to expose the GPU using OCI hooks. I've been working with some people to do that, and that will be a really cool project, but it won't use the operator because it's not supported on that platform at this point. So another thing is, so the K3s, I'm not sure. I couldn't find anything on whether I could use the GPU operator. And so because of that, I didn't feel like it was a safe choice anyways. So that was eliminated. And then you could use a kind, but kind of follows the same reasoning that I didn't use Minikube. So really, I think kubeadm is the best way to go. That would be my recommendation. So my install is kubeadm on top of Ubuntu 2004. And that's what my server is running. So those are my decisions. That's what I did. Now, when you're going to set up your machine that you're going to run this on, the very first thing that you want to do is to disable swap. That's going to be sudo swap off -a. And you're going to want to go into the fstab file and remove the swap partition. You can comment it out or delete it depending on how comfortable you are with editing that file. So you're going to want to do that and then reboot and make sure that swap stays off. If you don't go into the fstab when you reboot, swap is going to turn back on, and you're going to have, it's easier just to go into the fstab, comment them off. When the reason you want to turn off swap is Kubernetes Scheduler. So I probably should do a whole series of videos on schedulers, and schedulers are a whole interesting topic in themselves, but the Kubernetes scheduler specifically wants to own every piece of memory, and it wasn't designed to handle swap. So it wants to pack your applications in as tightly as possible in the memory that's allocated. And because of this, they made some decisions, and the decisions they made were to make sure swap was turned off. If you don't know what swap is, 50,000 feet, swap is a way for the Linux OS to swap some memory into your hard drive and swap memory around to kind of fake expand your memory in an intelligent way. Anyways, moving on. So the first thing you're wanting to do to prepare your machine is to turn swap off. The next thing you're going to want to install two things. You're going to want to, the first thing that you're going to want to install is the Kubernetes. You're going to want to install the Kubernetes binaries or packages, whatever your distribution holds. So again, all of these instructions should hold true to whatever Kubernetes distribution or OS distribution you're using, whether it's Arch, whether it's OpenSUSE, these are the same things. Whether your package manager provides them or you have to go get the binaries or whatnot, that might change, but for the most part, you need to go get the packages. So you have the Kubernetes packages, but you're not quite done. There's two things. The second thing that you need, or first thing, I'd probably get it, it doesn't really matter, is your container runtime. Now, because I want to run the GPU operator and on Ubuntu, the GPU operator on Ubuntu supports Docker. And because of that, I had to use Docker. Again, GPU operator has actually dictated a lot of my choices for me. And this is why it's important when you go to design your cluster to know what your requirements are for your cluster, to make sure that the choices you make at the very beginning don't bite you in the derriere later on. So I'm going to be running with Docker 19 something. I don't remember. Docker 19 plus. And that was pretty much decided for me. So those are the two things. Container runtime, it can be Kata, it can be, I almost said Cilium. It can be Kata, it can be Cryo. There are different options out there that hold to the open runtime container spec, and you can use whichever one you want. I will leave a link to some of the main popular ones. I think those would be Kata and Cryo and Docker / Containerd. Now we've installed everything that we need to install, and we've turned swapped off. Really, the only last thing is to use kubeadm. So I said download the Kubernetes binary. In that statement, you also needed to make sure that you had the kubeadm package. It should be packaged alongside Kubernetes. If it's not, you're going to need to get that binary and make sure that it matches the Kubernetes version you want. I'm doing Kubernetes 1.18. So now you're ready to install it with kubeadm. Here, I highly recommend when you install with kubeadm to install it with a control plane endpoint. So what this control plane endpoint does is it configures your Kubernetes cluster to point to some other machine or some other IP or some other DNS name for the control plane. And what happens is if you have multiple control planes, your nodes won't load balance to them. So if they're hard-coded with the first control plane's IP address, so in our case, 10.1.1.50, then the requests aren't load balanced across the cluster. And if your first control plane node goes down, your second one won't get any of the requests, and all the requests will fail. And that kind of defeats a lot of the purpose of having multiple control plane nodes. So what this means is that if you're going to ever expand to another control plane node, which we very well will, you want to have a load balancer. Now, it can actually be on the same node. And if you put it under a DNS entry, you can then remap that DNS entry. So in ours, we're going to use HA proxy. And behind DNS, a DNS name. And then you can map that DNS name to another node if you want to move the HA proxy or whatnot. And all of that then happens seamlessly behind the scenes, and you don't have to reconfigure your Kubernetes cluster or your keys or your certs, and all of that is easily maintained and is pretty transparent. So I highly recommend that you do this, even if you're just starting with one control plane node and you don't even have plans of adding a second one. I would do it. It's a good experience. And it's something that happens when if you're running your control plane in Azure or AWS or GCP, if you're running in one of these clouds, they do this for you. And or some of them like DigitalOcean, I believe DigitalOcean only has one control plane node. And I think that they pull some stuff that if that control plane node fails for some reason, it gets restarted instantly at a save. Anyways, I'm not exactly sure. I don't know all of their details, but I'm pretty sure that you don't get to add multiple control plane nodes. All right, so our home cluster, we have node 10.1.1.10 is our load balancer, and it is a Rock Pro ARM64 HA proxy. That's all it does. And this actually plays into more. I wanted this also to sit there because it's going to load balance incoming traffic. And I don't really need it to load balance incoming traffic, but it's going to handle upgrading from 80 to TLS and all of those things with the connections, as well as it's going to ensure that incoming traffic can't access the API server and vice versa. And all of those config files that are used are actually on the GitHub. So if you want to check them out, they're a work in progress right now. So you can check them out. You can comment on them. You can add updates to them. And yeah, go share. All right. So at this point, we can use kubeadm init. Init is what you do with the very first node. Everything else is join. So you're going to do init with control plane endpoint. And for me, I put my DNS name for my HA proxy as the control plane endpoint. And I had the control plane endpoint already set up. Well, at least some of the HA proxy is set up at this point, at least the part I need for Kubernetes. There are two things that happen. Their first, kubeadm is going to print out some commands. And these commands are going to tell you to copy a config file. This is your kube config file. I have a video on kube config files in my Kubernetes the hardest way. If you want to learn more about kube config files, go to that. I probably need to redo that video. I've gotten a little bit better. But that's a kube config file. And that allows you to communicate to your cluster. And it's actually going to hit HA proxy in my case to then be load balanced to my single node. Guard this with your life. Kube config files contain your credentials or can contain your credentials, and this one does. And this one actually contains your Kubernetes cluster admin credentials. So it can pretty much do whatever it pleases in your cluster. These aren't for storing in Git. They should never show up in Git. You can remove your credentials and put them in files and then put paths to your files. So you could manage them in Git if you did that with the certs, but just be wary. This thing that kubeadm spits out does have your credentials in it. All right, you're going to want to copy this out to a secure place to store it, and you're going to want to have it on your computer that you're accessing the cluster through. So go ahead and get that. What you're going to notice, you can now use kubectl if you copy that into your .kube file. You can use, or you can actually, you don't have to copy it. You can also do --kube config and give it the path to that file. You can use kubectl. And if you notice and run kubectl right now, with doing nothing else, it's going to tell you that you have one node, and it's going to tell you that it's not ready. And the reason this node isn't ready yet is it hasn't been configured with networking. And so it's not really ready to schedule stuff on it. And it knows that, but you need to install a networking solution. So really here I had two options. I had Calico and Cilium were the two options that I was really looking at. Flannel is not an option. Even in your home network, Flannel is not an option. All right, just maybe I should make a whole video on why Flannel isn't an option. I think Flannel is great, but it's not really an option. All right, so it was pretty much between Calico and Cilium, and I went with Calico. Cilium, I think, is the future. It uses Berkeley packet filters, BPFs, and it really uses really cool tech that's really, really cool. but it's bleeding edge. And for this, I pretty much just want this to work. So I used Calico because Calico is more of the tried and true tech that just kind of works. I think in the future, Cilium is really the project to go with. But yeah, for me, I wanted easy networking. I don't want to be dealing with networking issues. All right. So if you go to Calico's documentation and are going through it, we're doing an on-premise install. But the one thing that I wanted to point out is there's really two different ways of installing Calico. The very first way of installing Calico is for clusters of 50 nodes or less. Right now, I don't plan on supporting more than 50 nodes. And if I do, I'm probably going to stand up a new cluster. It's just going to be a new cluster. It's not going to be this cluster. This cluster is never going to be more than 50 cluster. The other way of deploying it is for 50 and greater. And the 50 isn't a hard, once you hit 50, you're screwed if you go to 51. And, maybe, yeah. So that's kind of up to your judgment, and how big your nodes are, I think also makes a difference. So the other way to install Calico is with the Taifa daemon. And basically what this does is it helps it scale better, because the more and more nodes you add, the more and more connections. And the Taifa daemon basically lets, without going into too much detail, one, because I don't know a ton of detail, but I know a high level, the Taifa daemon is going to manage all of these requests, and it stores its own data store just about the networking for those requests, the clients, so that it doesn't bog down the servers as well. So it's just there to enable scaling. But this is now another daemon that has to run. This is more resources. So it's not actually resource efficient to run it on small clusters. It actually takes up more resources than it saves. And then when you get into the larger cluster, it actually saves you more resources than it costs you. So this is why you have the two different types of deployments. So if you're following along, that's why I picked that style of deployment. And my YAML files for my deployment are there. I have them in the GitHub, but they are, at this point, the same as the upstream. Now, if we want to edit them and change them, if we need to in the future, we will. But for the time being, they are the exact same as what the Calico project recommends. I needed no changes to them. It works on the CIDR that I wanted them to work on. And once Project Calico is installed, you now should be able to run kubectl git nodes and see that the master node is working. We have one last step to do. Because we're doing a single node, the master node is tainted with a node-role.kubernetes.io/master. So it has this label on it, and the scheduler will never schedule something on a node that has that label. So, and that's literally the only thing that keeps it from doing it is that label. You could slap that label on another node that really is a worker node and has no control plane components, and it would stop scheduling stuff on it. So this is how Kubernetes kubeadm handles labeling masters to keep the scheduler from scheduling stuff on it. Because a kubeadm deployment has the kubelet on the node. So the kubeadm deployment uses static pod manifests. Static pod manifest is a fancy way to say the kubelet will take everything out of this directory and install it as a pod. These are static pod manifests. These aren't controlled by the daemon set controller. These aren't controlled by any controller in Kubernetes. They're static pod manifests. These manifests are static. They exist on the machines, and the kubelet, when it starts up, will run them. If you wanted to make a static pod, if you wanted to make a YAML file and stick it in here that defines a valid pod, it would get run on this node, and there would be no way to manage it through Kubernetes. I have to tell you that while kubeadm does this for your control plane nodes and runs your control plane nodes inside your container runtime. So that's another thing that this does is you can actually do Docker PS or cryctl PS and actually see your control plane nodes. So let's do that. And these control plane nodes are running under the system namespace. So this is where your control plane lives and exists. And while this use of static pod manifest is really cool and enabled really a very clean install. So a lot of installs before this, before the kubeadm way, were really messy and ran into a lot of problems. And this solved lots of problems. I can't tell you how many problems this solved. I think that this is the only place you should ever use static pod manifest. I actually don't recommend using it for just about anything else. You can probably come up with some strange way that it solves something better and cleaner. And I say probably, but I really don't think so. I can't stress highly enough. I am teaching you about static pod manifests, not so that you can use them, but so that you can understand how kubeadm runs the control plane. Please, for the sake of everyone watching, don't use static pod manifest to run anything in your Kubernetes cluster, unless you're running something at home for the fun of it to learn about static pod manifests. And then it should be the control plane components. Nothing else should be run as a, yes. Anyhow, everything else, it's better to run as like a daemon set. And this has a daemon set controller that manages it and allows for things like that. So please don't take this and say that Merrick said to run static pods. This is my disclaimer. I did not say to run static pods. This is how kubeadm runs the control plane. And this is why you can look at the container images here. Your control plane is now completely containerized. It is hosted in, it's not hosted in your Kubernetes cluster. There actually was a project in kubeadm. I actually kind of pushed for it. So the people that work more on kubeadm than I get to can testify that I really wanted to keep it alive because I liked the concept. The concept was cool. It was messy though. But basically, kubeadm would use the static pod manifest to start your control plane. And then it would take them out of being static pod manifest and host them inside the cluster. So now your control plane was a Kubernetes centric and manageable by the Kubernetes control plane itself. So you could schedule control plane components wherever you well pleased. This caused issues. This caused lots of issues. And I think actually one of the biggest issues that this caused was if, let's say my control plane shuts down right now. And then, so I have a single control plane and I shut it down and I turn it back on. When you're hosting Kubernetes control plane in Kubernetes, this won't turn back on. It's super messy and it doesn't recover well from your control plane going down. Right now, it doesn't matter. I can turn it off, I can turn it back on, and it will be perfectly fine. And the kubelet has been enabled on the machine and will start automatically on boot. So, and as soon as the kubelet boots, it's going to load all of those static pod manifests that kubeadm installed. That was just a quick back history. Kubernetes inside Kubernetes, don't do it. There's problems. It sounds cool. And this is how kubeadm runs the control plane. What it means for your install and for my install is that the kubelet is running on all the machines, which means it can schedule pods on those machines. Now, if you watched and followed the kubeadm the hardest way, you'll notice that the kubelet was never installed because the kubelet doesn't technically have to be installed on a master node. You can run it without the kubelet because these are the control plane components. And if you notice, there's no kubelet in those. And it doesn't need to be there. But in a kubeadm way, when using kubeadm to install, which a lot of installers use kubeadm to install as the base, It's kind of the de facto installer at this point. Install the kubelet so you can actually run workloads on the master node. All right, so that's a little bit of a history. Static pod manifest, there'll be a link to the static pod manifest if you want to know more about those. I plan on releasing a video on those as well. I have so many videos to make. So that's how kubeadm installs, and that's how it is installed here. So all we have to do, and so in the Kubernetes the hardest way videos, it would actually be impossible for us to untaint our master nodes and have things scheduled on them. If you notice in those videos, whenever you do kubectl get nodes, it never actually wouldn't return the control plane nodes. And the reason is the control plane nodes aren't running the kubelet. So in a kubeadm install, though, you can just untaint them with this command and run workloads on your master node. That's all you have to do. It's that simple, that easy. Now that we've run this, you can run a test pod and watch it run, and you're ready to go. You have a Kubernetes cluster at home. Now, my cluster is far from done. We have so much more to do because really what you'll find out is if you run a Kubernetes cluster in GCP or Azure or DigitalOcean even, and DigitalOcean is one of the ones that does less for you than a lot of the others, they do a lot of things for you. Like I was saying with the HA proxy load balancer, they do a lot of these things under the covers. And since this is a learning experience for us, as well as just a way to have a rockin' awesome Kubernetes cluster in our home, we're going to have to do some of those things. We need to have app delivery. We need to have ingress. We need to have a way for the internet to get to our cluster. So while none of this is super hard, there's some pros and cons, and we're going to learn as we go, and we're going to find out why we have some of this stuff. Now, I obviously already did the load balancer, the HA proxy load balancer, and that was because that is really painful to go back and change. Really painful. Basically, reinstall the Kubernetes cluster is easier. So I saved us that one. But for a lot of these, we'll get to see the problems, and I'll show you the problems that happen when we try different things and why we do different things with ingress controllers and whatnot. And yeah, I hope you stay tuned for the ride, and I hope that this is a fun experience. I tried to stay out of the terminal as much as possible today so that we could talk about why I did what I did. And the commands are easy enough to follow. And I think I'm going to try to take this approach a little bit more, write a good blog article that steps through the commands, the terminal sessions and whatnot, and then do a video explaining why. Let me know how you like it. Leave a comment if you liked this episode versus other episodes. Give it a thumbs up. If you didn't like this video, let's be honest, why are you still here? But since you are, go ahead and give it a thumbs up, subscribe, and stay tuned for the next episode and see if it gets any better for science.